This is the screencast for 2.7, example 5, calculating acid mixtures. So how much pure acid must be added to 50 milliliters of 35% acid solution to produce a mixture that's 75% acid? That sounds really confusing. It's actually not too bad. Right now, we've got 35% of a 50 milliliter solution that is acid. So 35% of 50 milliliters is acidic. Now, if I add pure acid to that, I'm going to have a total mixture of 50 milliliters plus however much acid I add. I want that to equal 75% acid. So in other words, 0.35 times 50 is 17.5. So 17.5 milliliters of acid exist in this 50 milliliter container right here. So maybe right there is where the acid is. The rest of it's just pure water. So we're going to add pure acid to it. We're going to add that many amount of milliliters. Well, in the container total, there's 50 milliliters plus however many milliliters of acid I add. And I want that to be a 75% acidic solution, which means 75 out of 100%. 75 out of 100 milliliters need to be pure acid. So now I can multiply both sides by 50 plus x. Then I'm going to get the x terms on one side and the non-x terms on the other side. Divide both sides by 0.25. And I get x equals 80 milliliters. So in this 50 milliliter solution, if I add 80 more milliliters of pure acid, it was 17.5 milliliters of acid plus 80 milliliters of acid. And we had a total at the beginning of 50 milliliters. Now we're adding this 80 milliliters of acid. That will be, let's see, 97.5 over 130, which in my calculator is 0.75, 75% acid. The now try problem is number 31. Now they gave us the equation in this one and they're trying to ask us to make sense of it. So to read the original problem, suppose that x milliliters of pure acid are added to 125 milliliters of 60% acid solution. So similar to the previous example, we've got 125 total milliliters of solution, and 60% of that is pure acid. So like the bottom 60% is acid, the top 40% is water. Now we're going to add pure acid to make it more concentrated until 83% of the total mixture is acid. So part A asks us to explain why the concentration, which they're calling C of x, of the new mixture equals this mess. Well, that numerator represents the total milliliters of pure acid. 60% of the original 125 milliliters, which is 75 milliliters of acid, plus any milliliters of acid that we add. So these are pure milliliters in the numerator. Then the denominator is going to be the total milliliters in the entire container, 125 from the original solution, plus every time we add acid, we're adding more to the total volume. Now part B says, suppose the viewing window in the figure, this one, is used to find a solution to the problem. What is the equation of the horizontal line? Well, that horizontal line looks like 0.8 something, going back to the original problem. How many milliliters of pure acid must be added to obtain a solution of 83% acid? So that horizontal line is going to be y equals 0.83. That would be our C of x value. So in part C it says, write and solve an equation that answers the questions of this problem. Explain your answer. So I'm going to say my concentration is 0.83, and that's going to equal the equation they had set up for me. The total milliliters, so pure acid plus the amount of acid left in the original solution, and the denominator is the total number of milliliters in the entire container. I'm going to multiply both sides by x plus 125, get my x terms on the same side of the equal sign and everything else on the other side. Divide both sides by negative 0.17. So my answer is 28.58 milliliters. My explanation is that 28.58 milliliters of pure acid have to be added to this 125 milliliter solution of 60% acid in order to get a total concentration of 83% acid. So make sure and write down that explanation on your notes.